Hi everyone, now I'm going to explain about 2D heat conduction equation in MATLAB. So the steady state heat conduction is Laplace in nature, which is d square t over dx square plus d square t by dy square equals to 0. The discretization method is central space, and the final discretization equation is t I comma j equals to 1 over t of 1 plus beta into t of I plus 1 comma j plus t of I minus 1 comma j plus beta into t of I comma j plus 1 plus t of I comma j minus 1, and here the beta is defined as del x by del y whole square. The boundary conditions for this problem: the left wall is at 500 degrees centigrade, and the top wall is about 600 degrees centigrade, and the right is 700 degrees centigrade, and the bottom is 800 degrees centigrade. So let's switch to MATLAB. So clear all and close all to clean the workspace, and CLC command to clean command window, and the number of, so first of all the length is equals to 1 meter and height is equals to 1 meter, and the number of nodes in x direction is equals to 10 and in y direction is equals to 10. I have taken the very less number of nodes so that I can observe the coding. X equals to linspace 0 to L nx, y equals to linspace 0 to h ny. The temperature, initialization of temperature. Now temperature initially inner nodes are at 0 degrees centigrade, so I have given the zeros in x, comma ny, and the boundary conditions: t of left equals to 500 as from the problem, and t top 600. Let's check whether it is correct or not. Top is 600 and the first column is 500, which is left, and rightmost all the rows, which is about 700. And then the bottom row, all the columns, which is equal to 800. This is the initialization of the temperature. I'm defining the beta, which I have told about del x by del y whole square. I forgot to define about del x and del y, so I am defining it here itself. It is L by nx minus 1 dy is equals to h by ny minus 1. So error is equals to somewhat 565 and tolerance equals to 1e minus 6. So while loop, error is greater than tolerance for I equals to 2 to nx minus 1. So I have to solve only the inner rows. So the second row, the calculation going to from the second row. So I have taken 2 to nx minus 1. This is the last row, which is nx, and the before that last row, which is nx minus 1. For j equals to 2 to ny minus 1. So here I am writing the discretization equation, comma j is equals to 1 divided by 2 into 1 plus beta, and t of I plus 1 comma j plus t of I minus 1 comma j plus beta into t of I comma j plus 1 plus t of I comma j minus 1. This is the overall discretization equation, and ending for the for loops. So defining error term, which is equals to absolute maximum of t minus t old, and updating the t old term equals to t and closing the while loop. Now for the post processing, contour f x comma y comma t. So let's check whether it will come or not. This so it is coming. So we have to give the what is length and height for the x and y directions, and we can also give the title of this problem. So for that, and also we can also give the text to the counters at what counter how much temperature it is. So for that, I'm just adding the show test command. I'm just owning it, and then x label is nothing but length, y label, which is height. Now we'll see how it will look like. This before that we don't have any numbers at the counters, so now we can see the numbers 550, 600, 650 like that. So another observation is we have given the 600 at the top, but it is given 800, so we have to change this direction. So for that we have to give one command, and that is offset GCA and change the y direction, so y direction, and reverse. I'm just reversing the y direction, that's what I'm giving. and then title. So title of this problem is study state heat conduction. So let's run it. See, now the direction is changed to y direction. Now here you can see 1 here it is 0, and the title of the problem, study state heat conduction. So I want to include the number of iterations, how much iteration it has taken to solve this equation. So for that I am just giving iter equals to 0, iter equals to iter plus 1. So here another command which is printf. Backslash n to change the row number of iterations, %d, and here it is iter. Let's check what will happen. Is there any errors or not? See, now the heat steady state heat conduction and the row change to number of iteration. It has taken 150 iterations. Why it is taking less number of iterations? Because I given nx and ny, which is number of nodes is 10 by 10, which is 100 only. So now for that only it is just this is not in smooth way. So if I increase the number of nodes to a certain level, it will become smooth. So let's do that. So now I'm increasing the number of nodes to 10 to 100. So 10 to 100, and let's check. This is how the steady state heat conduction looks like. Now the iteration changed to 13,782 from the 542 something else. Okay, thank you.